Welcome back, AP Stats. We're going to take a look at the rest of section 3.2 right now and get that situated for your review. So we left off talking about S, R squared, and what we're going to jump into here is how to determine the least squares regression line if they just give you the summary statistics. And what I mean by those is the mean, the standard deviation, and the correlation of the variables. So in this question, they give you the means for each variable, the standard deviation for each variable, and the correlation. So what they're doing is they're using the formulas. Give me a second. On the formula sheet to do this. So this is your least squares regression line equation. It has a y-intercept and a slope. This is the equation you're going to use to calculate the slope. You're going to do this first using the correlation and the standard deviations. Once you get the slope, you're going to substitute that in here along with the means to find the y-intercept. So you're going to do this second. That'll find you the y-intercept. And then once you know A and B, you could substitute those values in to find the predicted y and x. You'll find your least squares regression line equation. So that's what they're doing here. They're finding the slope, 2.75. They're plugging that into the other equation with the means to get the y-intercept of 103. And then they're creating their least squares regression line equation. My only gripe with this is make sure you use context, don't have predicted y and x. All right, so let's talk about outliers. And we talked about outliers, influential points, high leverage points. So let's kind of talk about what those are. So in a scatter plot, a couple different kinds of outliers you can have. You can have an outlier in the y direction. It's going to have a large residual. It's not going to have much impact on the least squares regression line equation, but this is an outlier in the y direction. We say it doesn't have high leverage or it's not influential because it's not changing the line much. Like without that outlier, here's the line. I'll just do WO without, and then maybe with the outlier, it's that dashed line. Not much of a difference. But if you take some outliers in the x direction and the y direction, something like this point here, this is kind of an outlier in the x direction and the y direction. But this follows the overall linear pattern. So all this is going to do, it's not going to have really any influence. The line with and without is pretty much going to be the same. This is just going to strengthen the association. So not that exciting. Now, if we have a point that is something like this, where this is an outlier in the x direction and it does not follow the pattern, without this point, the line probably looks like this, the least squares regression line. When I add that point in, it's probably going to look something like that. And that's a huge difference. So we call this point influential. It's influencing the slope and the y-intercept of the line. And it does have high leverage because it's far away from the mean of x. So that gives it leverage. If you think about it like a teeter-totter, the further away you are from the center, the more leverage you have. Same idea here. It's worth noting that association does not prove causation. It never will. Whether there's a strong association or not between these two quantitative variables, that does not prove causation. Does not prove causation. So that's it for section 3.2. Hope you enjoyed.